So thanks for your time to join me to talk about multi-physics analysis with CST Studio. Appreciate your time. Without due delay, let's get to the point. I assume most of you are CST users, so by definition you are familiar with CST Studio Suite and you are expert in electromagnetic analysis. And CST is quite famous in this area, in the electromagnetic simulation capabilities, and you may wonder why we are bothering with considering other type of physics. So, but the truth is, for a long time, we don't have to, because computers were much weaker and people can simulate, were much simpler, and you can do one thing and do it really well, and that's wonderful. But today, things are changing. Well, don't get me wrong, there are still places for such dedication, for such do one thing, do it well dedication. But increasingly, people are designing devices with ever-shrinking margin, involve ever more complex physics. So for example, in the microwave RF and optical area, you may have to watch out for temperature-induced deformation to detune your filters. And for photonics, you may have to watch out for the deformation induced by heating and therefore change the behavior of your optics. And most lately, people are really working on the 5G devices. And this 5G base station, you have to design it carefully so that your device will get enough cooling and remain reliable and operated consistently. And especially in millimeter wave in the 5G domain, the size of the device are shrinking. So for example, the base station and antenna array are shrinking dramatically because the higher frequency. And they're much faster, but much hotter. And they're much more sensitive to heating. Sometimes you would have to use things like liquid cooling to maintain the temperature to an acceptable degree. And if we are undergoing some medical treatment, for example, this is hyperthermia treatment, like focusing some RF energy on this particular tumor, we need to understand whether the heating is effective, whether it's going to overheat the area that's not supposed to heat. So that's very important. We need to study that. Now, in the EDA and electronics area, which is maybe one of the area you're working on, and the last thing you want to have is such burned electronics. What you want is a nicely designed, streamlined electronics that work reliably and work cool. If you're in the area designing EMC, EMI area, then oftentimes the EMC issue is once the EMC issue is identified, you find out it was due to the lack of shielding. So in the